For the purposes of testing the Williams direct fluidizing mill concept, COMPCO has allowed Williams to modify this plant as will be shown. The purpose is to minimize 100 micron fines while crushing to variable product sizes varying from 1,000 microns all the way down to 300 microns average particle size. The coal is stockpiled in the open by means of a radial stacking conveyor and is recovered by a front-end loader and transported to a feed hopper equipped with a vibrating output feeder located at the bottom. The coal arrives at COMPCO's plant by railroad hopper car and is normally a -3-inch feed size.
Coal feeds down the hopper into the Williams 240 reversible impactor. The pulverized coal then discharges, drops onto a conveyor. This conveyor takes the pre-pulverized coal on up to the large feed storage bins for the pulverizer.
The pre-sized coal drops into one of two 100-ton storage bins. A gravimetric feeder is located directly below. At this time, the coal consist is 80% minus 1/2 inch, 57% minus 1/4, and it has 5.3% minus 100 mesh.
Okay, feed drops out of the large feed storage bin onto the weigh belt feeder. This feeder is running at its maximum at the present time, about 20 tons per hour. The feed is around 2-inch by 0. It's got from 8 to 10% moisture. The feed drops off of the belt down the chute into the mill's feed chute, dropping past the two flop gates. Talk about the feed. What do you see? 2-inch? Feed is anywhere from 2-inch by 0. It's approximately 7 to 8% moisture.
Directly below the feeder is the Williams DFM pulverizer that has been modified for this test.
Okay, feed enters the pulverizer through the chute back at the back of the chamber up above. Feed slides down the chute and drops onto this distributor plate. The feed is spun off the distributor plate, dropping over and where the fines are stripped away by the upflowing airstream. Okay, the feed drops down where it collects on the bottom of the mill and is fluidized by a combination of the plows turning with the mill's rotation and is fluidized by the air which enters tangentially through the wind ports from the wind box. As the material is, as the coal is fluidized, it is suspended in the grinding zone and is ground between the journal grinding rolls and the bull ring.
While this man is obtaining a sample of the upper discharge using a conventional sampling device, let us point out how the direct firing mill has advantages over conventional preparation systems. First of all, the fines, as shown here, are pre-stripped from the coal prior to entering the pulverizing chamber, as was shown earlier, as well as the fines that are developed during pulverizing, thereby minimizing the amount of fines. The same gases that strip the fines are used to pre-dry the coal so that it is easily handled. Coal containing 8% or even 14% moisture can easily be reduced to less than 1% in this system. To the right we see the input feed chute that connects to the gravimetric feeder located above. And now we have a sample of the top discharge of the DFM pulverizer. This output represents normally 1/2 of the total feedstock and has been dried down to less than 1% moisture. This product now contains all of the fines, both in the feedstock and those generated by the pulverizer. These fines have less than 1% moisture content. And
here underneath the Williams 74-inch DFM mill, the mill is powered by a 500 horsepower motor through a Falk right-angle gear reducer. The mill speed is varied through an AC variable frequency drive. The chute right here is for discharging material off the bottom of the mill. The material drops down out of this discharge chute through a open or closed slide gate and drops into the discharge conveyor.
Bottom discharge, you can see right down here, it's coming out of the bottom of the mill, being transferred into the front end loader via a slider belt conveyor. You can see there are relatively few fines in the bottom discharge, less than 0.1% minus 200 mesh.
50% of the feed reports as product to the bottom of the DFM pulverizer. So now, if we mentally combine both the top and bottom discharge of the pulverizer, we have a product that is dry and that is 98% minus 1/2 inch with only 10% minus 100 mesh, of which 5% arrived in the feed material.
Pulverized coal leaves the pulverizer at the top of the pulverizer and travels up the pipe past the explosion vent Y and continues up the duct to the top entrance of the cyclone. The pulverized coal then is separated in the cyclone. The discharge drops out of the cyclone down the discharge chute past a rotary valve, drops over a Milltronics weight plate, and then dumps into a screw conveyor, which transfers it to another screw conveyor, which then transfers the finished product into a waiting truck. Exhaust from the cyclone travels out of the cyclone outlet through this duct and past the manual damper here into the main fan. Now, the normal application would be for the Williams computer to automatically vary the air speed to tailor it to the needs of the pulverizer. The fan is automatically controlled through a variable frequency AC drive. Exhaust from the fan is injected into the wind box, where it then enters the mill tangentially through the air ports and also mixes with the hot gases. Dust-laden air is taken off from the positive side of the fan, where it then travels up to the bag house for collection. Williams 6 million BTU air heater is fired by dual fuel. Here is the natural gas train, and over here is the Bunker C oil, heavy oil train, which can also be used. This is hot gases through the expansion joint and on over where it empties into the wind box of the DFM pulverizer. The hot gases enter the wind box and then enter the grinding chamber tangentially through